see a lot of advertisements on the internet and things. For instance, on the left here is 7 ways to cut your Alzheimer's disease risk, and it lists these 7. It's really small. You probably can't read it, but I want to point out to you that it says number 4 is make vitamin B12 a priority. Number 5 is choose your multivitamin wisely. So there are people out there saying, hey, you can cut your Alzheimer's disease risk through supplements. But is it really true? Okay. Up here we have vitamin B12 and memory, folic acid. These kind of work together to some extent. Down here we have vitamin D, which I'm going to touch on a little bit here tonight, I think. But mostly what I'm going to talk to you, and I'm going to teach you a new word, and that's a word called homocysteine. So homocysteine is an amino acid. And the way you should think about it is that when this amino acid becomes elevated in your blood, it's very much like cholesterol. So you all know that high cholesterol is related to heart attacks and strokes and vascular disease and that sort of thing. Well, you should think of homocysteine in the same way. When it becomes elevated, it is a risk factor not only for vascular disease, but for Alzheimer's disease and dementia and cognitive decline. But I'm going to tell you the story because the story is very interesting and nuanced, and I want you to hear it so that you understand a little better about how to think about these things. And one of the key things to remember is that one of the main reasons homocysteine goes up in your blood is that certain B vitamins, if they are low or deficient, will cause this to happen. All right, but I'm going to start with the downer. All right, and this was what you have to understand is that, and I realized this when I was preparing this talk, is that my first academic publication on homocysteine and cognitive function and dementia was 25 years ago, right? And I was like, wow, we've been doing this for 25 years. That's a lot of effort to put in to have somebody come along with a press release that says taking B vitamins won't prevent Alzheimer's disease. And looking at that going, no, that's not right. I know, I've been doing it for 25 years. But this press release said taking B vitamins doesn't slow mental decline as we age, nor is it likely to prevent Alzheimer's disease, conclude Oxford University researchers who have assembled all the best clinical trial data involving many, many people for the final answer on this debate. And I'm here to tell you that this is, well, I won't use the word I wanted to use. By the way, this is the publication from the American Journal of Clinical Nutrition that is behind this press release. This journal is one of the top nutrition journals in the world. Okay, so they don't publish usually bad things, but that's the case. So then later on in 2014, there was another press release, this time from BBC News, Dementia Study Questions Advice on Taking Supplements. This is the reference is in a journal called Neurology, which is one of the top journals in the field also. And again, we have this story. So if Oxford and the BBC proclaim it, then it must be true, right? Well, no. So the question for us tonight is, do B vitamin supplements prevent cognitive decline? And the answer, I believe, probably, but the devil is in the details. So let's look at some of the details. Hopefully I'll keep you awake. Now, some of you may be biochemically inclined. Most of you are probably not biochemically inclined. However, I will tell you something. I'll just digress here for a second. When I teach my students, I tell them that they are all biochemists, even though some of them are English majors and that sort of thing. And the reason I tell them that they're biochemists is because nutrition is actually applied biochemistry. Every time you stick something in your mouth and digest it and it goes into your body, you are playing with your biochemistry. And sometimes that sets off a light bulb in their heads. They're like, wow, it actually means something, what we're learning. So some of you may be interested in the arrows and the words. This is homocysteine, this is amino acid. It gets metabolized. But the important thing to take away from this is that folate, vitamin B9, vitamin B12, which is also called cobalamin, vitamin B6, which is also called pyridoxine. If you are low in those vitamins, homocysteine will build up in your cells, it will spill out in your blood and become elevated in your blood. And we can measure that, and when we do, we can say, oh, wait, there's something wrong here, and that this might prompt us to give you B vitamins. And also, it increases your risk of vascular disease like heart attacks and strokes. Now, this is where the 25 years come in. This is the article that I and one of my mentors, Irv Rosenberg, published when I was a graduate student at Tufts University. We wrote a review article, and in there we made the statement, it turns out to be one of the first statements, if not the first statement in the literature, that connects vitamin B12, B6, and folate deficiencies and homocysteine, this amino acid I'm going to tell you about, to what we call cerebrovascular disease, so vascular disease in your brain. And that this might be behind the cognitive disturbances that are associated with low levels of these vitamins. And so I'm going to show you some numbers, going to show you some graphs. This is one of the highlights or the seminal publications in this field from 1998. And you know what's really ironic about this? This was published by Dr. Clark, who is the same person who published that paper that said there's no benefit. So he was one of the first people who showed this relationship. And what this is telling you is that if your homocysteine is high, the odds of you having Alzheimer's disease at that time, so this is what we call a case control study. We compare people who don't have Alzheimer's to people who have Alzheimer's, and we say, what is your homocysteine level? And more people with Alzheimer's disease have high homocysteine in their blood, 4.6 times higher. Older adults with high homocysteine are more likely to have Alzheimer's disease, and vice versa. And the reason I say vice versa is we don't know in that kind of study what's cause and what's effect. You could get high homocysteine because you have Alzheimer's disease rather than high homocysteine causing Alzheimer's disease. But this was really important because it was the first study that actually verified on autopsy that the people had Alzheimer's disease when they were alive. And that's a really important thing because the definitive decision on whether you have Alzheimer's disease is at autopsy, right? In the time of this study, I would say that the clinicians, like John, were probably about 70% accurate in predicting whether you had Alzheimer's disease. 85 for John, maybe. But I will tell you that now they're probably in the 90 to 95% range, getting it right. But you still need that autopsy to be perfect, to get it exactly right. So anyway, high homocysteine associated with this disease. All right. So the next seminal study I wanted to show you was this one by a group led by Dr. Seshadri. And what this is telling you is when you take older adults who don't have a diagnosis of Alzheimer's disease and you follow them over time, in this case all the way up to almost 12 years, and ask who gets Alzheimer's disease, what you find is this dark, the solid line, these are the people with the highest homocysteine, and they get Alzheimer's disease at a higher rate than the people who have low homocysteine. All right, so to put that into words, older adults with high homocysteine are more likely to be diagnosed with Alzheimer's disease or dementia in the future. So this is starting to get more towards cause and effect, right? That this is something that happens before the disease. All right, so now I want to tell you about the Salsa study. And this is an appropriate name study because it's a Sacramento area Latino study on aging. It is a community-based cohort study, blah, blah, blah. But what you should know is that this study was done right here in the Sacramento area with a woman named Mary Hahn was the PI of that study. Many members of the Alzheimer's Institute here were involved in this study. It actually kind of is going on still at this point. In fact, I think she's moved on to what she calls the Nino study, which is the offspring of these people. And the Salsa study has been very, very good to me. These are the many publications that we have put out on this population, many of them related to B vitamins, homocysteine, cognition, dementia in this population. So I wanted to show you some of these data so that you can get a sense of why I think this area is important. So breaking a lot of work down into one table, what you're looking at here is data from 2 studies. Me was the lead author on one of my graduate students, Marissa Ramos, who now works for the California Department of Health, was the author on the other. And what you're looking at here is different cognitive function tests. So we have the neuropsychologists have a way of assessing how well your brain is working on a psychological level. So the first test is just a global test. This is mainly a screen. You come in and they ask you a bunch of questions, ask you to do a bunch of things, and you get a score. And the higher the score, the better your cognitive function. And then they have other tests that drill down into specific cognitive functions. So delayed recall is a short-term memory test. So it's something like I might give you 3 words to remember and then distract you with some other task and then come back and ask, what were those 3 words? I'm not going to try that on you tonight, right? But that's short-term memory, where you have to remember something after a little bit of time. Ability to name objects, so they give you a bunch of pictures and you have to say, oh, that's a chair, and that's a building, and that's a tree. And then there's more, there's long-term memory tests, there's attention and visuospatial skills, all different domains, and executive function, which is probably the most challenging tests, because this requires you to sort of follow directions and do one thing lead to another and that sort of thing. So these are all different kinds of tests. And what we found, just to break these studies down very simply, both your folate or folic acid status and your homocysteine level are both associated with your global cognitive functioning. That as your folate level goes up, you have better folate status, you have better cognition, and as your homocysteine goes up, you have poorer cognition, right? But notice that when we look at the subdomains, folate was associated with memory, short-term memory. Homocysteine was not, while homocysteine was associated with some of the others. So basically what this is saying is that both of these things are important. And while they are related to each other biochemically, they are associated with different things. They're independent of each other as well. We then went and asked, what about dementia? That was cognitive functioning, but what about clinical dementia? And we found that without going through those numbers, just get to the point, is that both folate and homocysteine were important. So older adults with low folate status, so low vitamin status, or high homocysteine are more likely to have cognitive impairment and dementia. We then asked the question, what about over time? What if we took the people who didn't have dementia or some sort of clinical cognitive impairment and asked, does homocysteine or folate predict this, the development of cognitive impairment or dementia? And so what you see here, what is being shown here, is that older adults with high homocysteine, just like we saw before in the Shishadri study, but not low folate, are more likely to be diagnosed with cognitive impairment in the future. So you might ask, well, why not low folate? Well, what happened in 1998 was we put all this folic acid in the food supply. And here's your memory test. Why did we do that? Neural tube defects, right? Okay? So it seems to us, based on our data, that not only prevented neural tube defects, but now folate wasn't associated with dementia later in life. We think that folic acid being put in the food supply actually reduced some of the dementia in our population. We haven't proven that, but we think that these data are consistent with that. However, the homocysteine was still important. And what these data are showing, this one's even more, that graph is even more complicated. I'll just avoid even going into it. But the bottom line is that vitamin B12 comes into play. So older adults with high homocysteine, because of low vitamin B12, are more likely to be diagnosed with cognitive impairment in the future. Okay? So what this is telling us is that high homocysteine and low B12 may be really important. And now I want to show you some data from a collaboration we had with University of California at San Francisco. And this is a really interesting study because the people in this study were chosen even though their average age is about 72 years and their education level was very, very high, all right, college and post-college education level, they were very, very healthy. They were chosen for being very, very healthy. No apparent cognitive impairment, very little disease like diabetes and heart disease and that sort of thing. This was a healthy aging study. They wanted to see what were the characteristics. And you can see here that their folate levels, nobody was deficient. Very few people were deficient in vitamin B12, so that goes along with their healthiness. Their homocysteine level, I can tell you this number is relatively low. However, there was a small percentage who had high homocysteine. And also down here, this number here, creatinine, some of you may know that from maybe getting it measured. This is a measure of your renal function, your kidney function, and there was, as expected in an age group this high, there was some renal dysfunction going on. But in the screening test for cognitive function, they on average scored 29 out of 30, which is really, really good. If you scored 29 out of the 30 on this test, the neurologist would send you home, you're doing good, we'll see you next year, right? So these were really healthy cognitively. But what I can tell you is even in these really healthy people, we found associations with homocysteine and the volume of brain in certain regions. So using MRI, we were able to see that very important regions related to Alzheimer's disease and dementia and memory and this sort of thing, things like the hippocampus, which is here, the amygdala, the basal ganglia, the thalamus. These are all regions that are really, really important. And we found that as homocysteine went up in this population, the volume in these areas of the brain went down. So this is a really early indicator. We also found that there are things called ventricles in your brain, which are really kind of holes in your brain that are supposed to be there. They're filled with cerebrospinal fluid, right? But they shouldn't be too big. And when they're too big, that means you're losing brain. And we also found the homocysteine was correlated with that. So these are the numbers. I'm just going to skip that. But we then went on to ask, okay, is this associated with cognitive functioning? All right, so maybe they've lost a little bit of brain, but maybe their cognition is still pretty good. Well, we found that when we looked at global cognitive function, there was no relationship with homocysteine, just sort of general screen. Some basic things like being able to process words, basic memory tests, none of that was associated. But when we got to the harder cognitive functions, what we call executive functions, we started to see significant correlations in a bad way. So what we think is happening here is, first of all, high homocysteine serves as a very early indicator of brain atrophy, loss of brain, and cognitive impairment in apparently healthy older adults. And we think that homocysteine can serve as a canary in a coal mine. Are you all familiar with that concept that in coal mines they'd have a little canary, and if the canary fainted, you better run because there were gases being released that was going to, because the bird was so small it would be affected first before the humans. Well, we think that homocysteine might be one of these canaries. So if you go to your doctor and you have it measured and it's elevated, that might be an early indication that something's going on or will be going on with your cognition and your brain. Now, I depict this here. I use this figure that I found from the internet, that this canary has a pickaxe, and the other question is whether or not this homocysteine is actually causing the damage or if it's just a marker. We don't really know. So that's why the canary has a pickaxe. All right, so now I'm going to take you through this figure because this figure is the most exciting thing that I think I can show you tonight. And I want you to appreciate what's being shown here. So I'm going to take a few minutes to go through this. This is a study by Dr. Smith, and Dr. Smith actually came to visit UC Davis a few years ago and presented these data. He's from the UK, and they took a group of people who have what we call mild cognitive impairment. So they're not normal, but they wouldn't be classified as having Alzheimer's disease or dementia. But they're probably on their way, okay? So they're in decline. And what they were doing was that they were taking MRI images of the brain, and the first thing they did was they said, how much brain do you have? What's your total volume of brain? And then they said, how is that related to your homocysteine level? And if you look on the left side of this figure, and I'll try to take you through it slowly. On the bottom is your homocysteine level in your blood increasing, okay? And on the left is the rate at which your brain is being lost each year in percent. And in this group of people, they ranged in a loss of brain per year of around 0.5% all the way up to 3 and above 3%. Think about that. If you're losing 3% of your brain every year, in 10 years, 30% of your brain is gone. That is serious stuff, right? And so what's really fascinating about this is that your homocysteine level is predicting how fast it's going. So if you have a low homocysteine, a normal homocysteine level, you're at the 0.5%. So in 10 years, it's 5% loss. But if you're at the higher levels of homocysteine, now you're at 2%, 3%, and that's 20%, 30% over 10 years. But what was really, really cool about this study is that they took people, half of the people, they gave them B vitamins, and those B vitamins lowered their homocysteine level. And, and what you see here is what their homocysteine level was at baseline. And what you can see with some variation is that whether they were low at baseline or high, now they're flat, okay? Which means that the B vitamins were slowing that loss of brain even for the people with the highest homocysteine levels at the beginning of the study. And that is really, really important, really, really dramatic. It says there are some people who will benefit from these B vitamins. Now, to give you a sense of what we're talking about, this is, the lights are a little bit bright. You may not be able to appreciate this, but this is comparing two people who started with high homocysteine of about the same, 22 or 24. This person got placebo, and their homocysteine actually went up. This person got the B vitamins. Their homocysteine was cut in half. And this person's loss of brain per year was 2.5%, and this person's was only 0.46%. And the way you look at this is an overlay. This is the baseline picture of the brain, and then everywhere that you see color is loss of brain over 2 years. And if you look closely, if you were those in the back, if you came up, you'd see there's a lot more color in this one and a lot less color in this one. All right, so that gives you an image. And then this is probably a little too complicated, but then when they looked at specific regions, they were able to confirm their finding. So B vitamin supplements slow brain atrophy in older adults with mild cognitive impairment and high homocysteine. Now, I want you to understand, this is the nuance. These are the caveats, right? It's not all of you. It's not all older people. It's people with these specific characteristics that are going to benefit. And that's what's lost when it goes to the press. But before I get to that, more on that, I just wanted to show you that this also plays a role in cognitive function. People with, I'll just go to the final result here. The people with high homocysteine, so above 11.3, those who got B vitamins maintained their memory on this memory test over the 2-year period. That's the blue lines. But the dark lines, the black line, is showing you that the ones who got placebo after 2 years have started to lose their cognitive function. So there's an association between this loss of brain and loss of cognitive function. So B vitamin supplements slow cognitive decline in older adults with mild cognitive impairment and high homocysteine. This is Dr. DeCarli's graph that it gives you an idea of what is happening to your brain over time as you age. So Dr. DeCarli is the head of the Alzheimer's Center here at UC Davis, and he would be here tonight, but he's celebrating his birthday, so he needed to go home. What I wanted to show you, sorry, I jumped ahead a little bit. What I want you to appreciate is that this is time at the bottom, and in black is what we're calling brain injury. So that could be Alzheimer's disease, vascular disease. It could be being punched in the head a lot, concussions, this sort of thing. Over time, we will develop injuries to our brain for various reasons. Some people develop less of that injury as they get to be 80, 90 years old. And some people develop a lot more, and they cross a threshold, and they're impaired cognitively, or they have dementia. And then looking on the left, the blue, cognitive ability, and the red lines, this is what happens to your cognitive function over time. And some of you, I hope everybody in this room, will have this line, or maybe a little loss of cognition when you get older, but it will remain fairly good. And you probably all know people like this. They're 90 years old, and they're clear and lucid as can be. Then there are others who may decline a little more quickly, and they might, when they're fairly old, may have, fairly minor cognitive problems. They forget this or forget that, but they're doing fairly well. Then there are other people who follow these trajectories where they're declining quickly, and then they fall off the table, and they become into in dementia and Alzheimer's disease. And so what I just showed you in all those data that I showed you, the Clark study, the other studies, Shishadri, the Salsa study by Mary Hahn, Dr. Smith, and then the study that we did with UCSF, which I hope to write up and publish this summer. At every stage of this, homocysteine was important. It was high at every one of these stages. Okay? So all of these data all together really are really good circumstantial evidence that this is important, and that you should conclude that we should be taking B vitamins to lower homocysteine, and we can maybe prevent or slow things down. So taken together, these data suggest taking B vitamins, lower homocysteine, prevent, slow cognitive decline at older dose. So I'd ask you, are you convinced? Yes. Well. I remind you that of this paper, this press release, right? And so what I wanted to explain to you is what's going on here is what's called a meta-analysis. And a meta-analysis is when they take many, many different studies and they put them all together. And in fact, it's funny, you can make quite a good living in science being somebody who doesn't do any of the research at all. Just takes everybody else's and stick it together and analyzes it statistically and writes papers like this. Okay? But the power of these studies is that there are a lot of people. The more people, subjects, that you can put together in these statistical analyses, the more power you have to see associations and see connections and make definitive decisions on whether something is real or true or not. Okay? And that's why they're done, and they're really important. But what I'm here to tell you is that when they're not done well, or if they're done well but they're asking the wrong question or they're using the wrong people, wrong studies, they can give you entirely the wrong answer. And in this case, I actually think it's a bit dangerous what happened. Okay? So let me show you, again, sorry about these graphs, but basically these are the studies that they put together, and then they get an average of all the studies. And what you're seeing here is that if this symbol that they came up with to represent all of the studies was to the left of this center line or to the right, it tells you that B vitamins are better or worse under these circumstances. And what you can see here is because this symbol is straddling the line, it's telling you that they believe that the vitamins don't work. They don't do anything. They don't make you worse. They don't make you better. And then there's a second aspect to this study where they're looking at the different cognitive domains like memory and thinking speed and executive function. And again, all of these things, their conclusion is that they don't do anything. A colleague and I from Wales, Andrew McCadden, got really kind of pissed off, miffed, thank you, miffed. And so we did what academics do. We write a paper that, if you look at the title, we're talking about somebody called Bradford Hill and meta-analyses and causality. It's very academic, right? But what it truly is an excoriation of that study. All right? And there are a lot of things we found wrong with this study. But I underlined in our abstract to this paper the most important thing I want to get across to you. And that is careful examination of the trials in the meta-analysis indicates that no conclusion can be made regarding the effects of homocysteine lowering on cognitive decline, since the trials typically did not include individuals who actually experienced such decline. So let me give you an idea of that. Remember the second press release? Well, if we look at that study carefully, I'm sorry about the low numbers, but the small type. But basically, there are 4 different cognitive function tests, and they're comparing the placebo versus the B vitamins, and it's over 2 years. And if you look very carefully at this, all of the subjects who were receiving placebo, none of them were declining in their cognitive function. And so you can't prevent something that isn't happening. Right? So this is the nuance. This is the caveat, right? You have to pick the right people. There are not everybody. We could throw vitamins at all of you. And there'd be a percentage, probably a minority of you, who might actually benefit because you are of the characteristics that would benefit from those vitamins. That could be you have low B vitamin status, you have high homocysteine, you're beginning to decline in cognitive function. But the rest of you who are doing fine, and if there's some unfortunate folks who actually already are at the dementia or Alzheimer's disease stage, we don't think it's going to benefit you. And so that is the nuance that's lost in that press release that says it doesn't work. All right, so probably, but the devil is in the details. Now, key considerations. So I've already gone through this. Just to reiterate, we need to know what your cognitive status is. We have to ask the right question. What truly was asked in that study that we excoriated was not whether it would prevent cognitive decline or prevent Alzheimer's disease. What was actually asked in that study was whether or not B vitamins will improve your cognitive function. And that is a very different question, okay? And I would tell you that in most cases, that is not the question that we're interested in. We're interested in preventing decline. All right? And then, of course, it matters what your B vitamin and homocysteine status is. All right, so we're back to here. And what I wanted to just point out to you, so there's a difference between treatment and prevention, okay? And what I want to tell you is that the Alzheimer's disease process and the dementia and vascular disease in your brain, once it's progressed very far, it's asking a lot for vitamins to help you at that point. And what's really important is that we're talking about prevention. We want to get you early. We want to get you filled up with a good status of vitamins at that point. All right. And I think maybe there's one other version of this coming up. And there we go. And then one more click. And so this is what we've been talking about. Your homocysteine level, your B vitamins level, will it help you at this stage? So conclusions, B vitamin supplements best protect against cognitive decline taken prior to the development of brain damage due to Alzheimer's or cerebrovascular disease. B vitamin supplements may only be effective in those individuals with metabolic evidence of deficiency, such as high homocysteine, technical term being hyperhomocysteinemia. So now here's your take-home message. My practical advice for older adults, 60 plus. Go to your doctor, have your B12 status measured. You want to have what's called a total B12. That's a measure of all the B12 in your blood. But you also probably want to have something else measured. It's turned the science, I've been involved in this, the science in establishing your vitamin B12 status has progressed in recent years to say that measuring just your total B12 isn't enough. You need to measure some other things. There's something called methylmalonic acid, but we would recommend in this case, because we're talking about cognition, a B12 and a homocysteine. Your doctor, very likely these days, if you go to ask them you ask your doctor, please measure my B12. If they haven't already done it, they very likely will do it in this day and age. The homocysteine measurement, they might wait. They might say, let's look at your B12 first. Okay? Now, I haven't talked about vitamin D, but I'm now going to talk about it very briefly. But I also recommend that you have your vitamin D status measured. It turns out that deficiency, even in this region of the country where you're exposed to so much sunlight, and you know that sun creates, synthesizes vitamin D in your skin, even in this area, there is a lot of vitamin D deficiency and insufficiency. So the recommendation, now your doctor will very likely measure your vitamin D, even if you don't ask, but if you do ask, probably will measure it.